In this video, I am going to find the inverse of a matrix. We are given a matrix A, we need to find the inverse matrix. Finding the inverse of a matrix, it follows a standard process. So let's say we are trying to find A inverse. A inverse is given as 1 over determinant of A times adjacent of A. That's what it is. Now, if you look at this formula, you see that 1 is being divided by determinant of A. Now, remember, when you are dividing a number by another number, you have to make sure that you are not dividing by 0. So, which says that determinant of A cannot be 0. If determinant of A is 0, then if we divide 1 by 0, we are going to get a number that is undefined. So, then in that case, the inverse won't exist. So, just to give you a side example, if I give you an example of 0 divided by 5, you know it's 0. However, 5 divided by 0 is undefined. You can kind of think of it this way. If you are dividing 0 by 5, what number can you multiply 5 by to get 0? Which is going to be 0, because 5 times 0 is equal to 0. So, 0 divided by 5 is 0. However, if you divide 5 by 0, then you can think of what number can I multiply 0 by so that I end up getting 5. By the way, there is no such number. Okay, there is no such number that you can multiply it by so that you can end up getting a 5. So we call it undefined. However, we also sometimes call it infinity, but that's also another way of looking at the same concept, so division concept. I won't get into that, but the bottom line is here you cannot have determinant to be 0. Let's go ahead and find the determinant of A. Now, finding the determinant of A involves a standard process. As you probably know, you have to expand it either a row or a column. So, let's consider the first row. We are going to go along the first row. So, the first entry is 1, right? So, 1 has a positional value, row number 1, column number 1. So, you are dealing with negative 1 raised to the power 1 plus 1, which is just positive 1, right? So it's going to be this times, then if you ignore the first row and the first column, then you will be left with 0, 3, 3, 2, and the determinant of that is going to be 0 times 2 is 0, minus 3 times 3 is 9. Then I consider the first row, second column. Now please note, it's going to have negative 1 to the power 1 plus 2, okay, then times 4, okay. Then if you ignore the second column and first row, you will have 4, 3, 2, 2, and the determinant of that is going to be 4 times 2 is 8, minus 3 times 2 is 6, plus I look at the first row, third column, which is number 2, so I'm going to have negative 1 raised to the power 1 plus 3 times 2, then that has to be multiplied by, if we ignore the first row and third column, I'll be left with 4, 0, 2, 3. Then determinant of that is going to be 4 times 3 is 12, minus 2 times 0 is 0. Now I am going to simplify it. If I simplify it, I get the following. As you can see, this is just a simple straightforward addition, subtraction, multiplication and stuff. So just to give you one quick example, negative 1 raised to the power 3 is just negative 1. So negative 1 times 4 is going to give you negative 4. This is how I get it. By the way, here I should have put negative 1 raised to the power 1 plus 1 as well, because we are dealing with the first entry, first row, first column, but negative 1 raised to the power 2 is just positive 1, right? So now if you simplify it, we get determinant of A is equal to 7, which means that is not equal to 0. So in essence, we are not dividing by 0 here. So the given matrix A, its determinant is not equal to 0, which tells us that it does have an inverse. Now let's go ahead and find the inverse. The next step in finding the inverse is finding the adjacent of the given matrix A. Finding the adjacent of a matrix A is kind of like similar to finding the determinant, except that you don't multiply by the corresponding entries in the matrix A. So let's go ahead and just do it so that you can see an example. Let me just label this Aij being the ith row and jth entry of the adjacent matrix A. Now we need to find each of these entries in the adjacent matrix A, adjacent of A. Now let's go ahead and do the first one, A11, okay? First row, first column of the entry of the adjacent matrix A. Okay, now let's look at the first row here and first column here, which has a 1. So I'm going to write it as negative 1 raised to the power 1 plus 1, okay, times the determinant of the matrix. So if you ignore first row and the first column, then you will be left with matrix 0, 3, 2, 3, 2. Now the determinant of that is going to be 0 times 2 minus 3 times 3. So it's going to be 0 times 2 minus 3 times 3, which is going to be negative 1 to the power 2 times 0 times 2 is 2 minus 3 times 3 is 9, so it's going to be negative 9. Now you know negative 1 whole square is just 1, which is going to give me negative 9. So my first entry is going to be negative 9. Now let me go ahead and find the second entry. Similarly, A12 now is going to be negative 1 raised to the power 1 plus 2. Now first row, second column. If I ignore the first row and the second column, I'll be left with this matrix 4, 3, 2, 2. So determinant of that is going to be 4 times 2 is 8 minus 3 times 2. So 4 times 2 minus 3 times 2 is going to be equal to negative 1 raised to the power 3 times 8 minus 6. 4 times 2 is 8 minus 3 times 2 is 6. Now negative 1 whole cube is just negative 1, right? Times 8 minus 6 is 2, that's going to give you negative 2. So the second entry is going to be negative 2. Similarly, the third entry, A13, is going to be negative 1 raised to the power 1 plus 3, right? Times the determinant of the matrix 4, 0, 2, 3. That's the matrix we get by ignoring the first row and the first column. So now we get 3 times 4 or 4 times 3 minus 2 times 0, which is going to give me the following. Negative 1 raised to the power 4, 1 plus 3 is 4, which is just going to be 1 times 12 minus 0 is going to be equal to 1 times 12 minus 0 is equal to 12. So this entry is going to be 12. Now I'm just going to do one more so that you get a feel for it, and then I'm going to write it out everything just to save some video time. So second row, first column, so it's going to be A21, okay? So it's going to be negative 1 raised to the power 2 plus 1 times, so if we ignore the second row, first column, we get a matrix 4, 2, 3, 2. And the determinant of that is going to be 4 times 2 is 8 minus 3 times 2 is 6. So it's going to be 4 times 2 minus 3 times 2 is going to be equal to negative 1 raised to the power 3. 2 plus 1 is 3 times 4 times 2 is 8 minus 3 times 2 is 6. That's going to give you the following. Negative 1 whole cube is just negative 1 times 8 minus 6 is 2. That's going to give you negative 2. So this entry is going to be negative 2. Now if you do the calculations exactly the way I have done here, you should get the following. So just by following the same process, I found the other terms, and our final adjacent of matrix A or adjacent of A is this. So this is the final adjacent matrix that we got. Now we are just going to have to plug in these values. We found the determinant of A, which is 7. We found the adjacent of A, which is this matrix. Now remember the definition of inverse matrix, which is this. Inverse of A or A inverse is 1 over determinant of A times the adjacent of A. We found the determinant of A to be 7, remember earlier we found, so it's going to be 1 over 7 times this adjacent matrix, which is this. Now if you feel like you can go ahead and multiply each of the entries in this matrix by 1/7, or if you can just leave it as it is, it doesn't matter. So this inverse of the matrix A is this. By the way, please do keep in mind this is a very standard process and you should follow it pretty much for all the matrices when you are trying to find the inverse of those matrices. Standard process, find the determinant and make sure that the determinant is not 0, and then find the adjacent matrix by following this process, and then multiply the 1 over the determinant times the adjacent matrix. Okay, so that's what the whole process is. I hope that this discussion was helpful. Thank you very much.